Hello, welcome to another class with me. My name is Ming. Today we're going to look at this particular learning target. Find the line of intersection and the angle between two planes. All right. And when we are considering two planes, these planes can be like this, that are not intersecting at all. So you can think of this as two planes. This is on the second floor and this is on the first floor. So there are no intersection. Or you can think of these two planes as intersecting in a line, like pages in the book, right? This is page 1, page 2, page 3, and so on, pages in the book. And you can also think of three planes intersecting like this. That is, in here, the three planes, one is the wall, this is also a wall, and this is the floor. And they're intersecting at a corner in the house. Two planes can also be, so in this particular case, there is here no solution, right? Over here is no solution. Over here is a unique solution. The solution is just at the corner. A unique solution, right? Just the corner. That is this, a unique solution. And over here, a line. The two intersect at a line. So there are so this is a line, the intersection is a line. And you can also have two planes like this, where you can think of this is plane, this orange plane, and over here is the blue plane, and then they are intersecting in such a way that are one actually inside the other. You can see that the color is changing from blue into purple. So here we have multiple or infinite number of solution. Infinite solution, right, in this case, right, because one is in the plane of the another. So there are many intersections. You can see that, right? Here's the orange color, and here's purple and blue, and then when they are on top of each other, the colors change into purple, right? So one is in the plane of the another. Next, we look at this particular question. Given two planes, one of them is here, right, in black color, and the other one is in blue, right? So these are two planes. Find the acute angle between these two planes. Now, in order to find the acute angle, we basically need to first identify the normal vector. So the normal vector for the first one, right, for the first, the black line is this, right, 3, 1, and -2. So here we are, 3, 1, and -2. And the second one is 2, -8, and 4, 2, -8, and 4. So given two planes, you can see that the angle that we really want is this. That's the angle between the two planes. This is the angle between the two planes that we really want. But this is the same as the angle between the two normal vectors. All right, so we let theta to be the desired angle, that is, of the two planes over here. And we just have to use the, right, because this question is about acute angle, so I have to make sure that I have the absolute value here. So to restrict cosine theta to be in the first quadrant, and so have 6, -8, 3 times 2 is 6, 1 times -8 is -8, -2 times 4 is -8. So 6 minus 8 minus 8. Down here is 3 square is 9, 1 square is 1, -2 square is 4. Similarly here, this is the magnitude of the first normal vector. Second normal vector, the magnitude of the second normal vector is here. 2 square is 4, 8 square is 64, -8 square is 64, 4 square is 16. So this is square root of 14, square root of 84. And then these simplify to 10 over square root of 14 over square root of 84. Now you can use the calculator. See, this is arc cosine. Make sure your calculator is in the radian mode like this. So now is arc cosine is this button. Arc cosine over here. And then I put in 10. Right, 10 here. Put 10 divided by square root of over here, square root, this one, right, square root of, what do we need? 14 times 84. So right now we go back to 14 times 84, right? And then press enter. So my answer is 1.27 to 3 significant figures. Okay, 1.27 to the 3 significant figures. That's the angle. So this is the acute angle. Next, we find the equation of the line of this intersection. That is this line here, right? The line along the 2 pages. All right. So, right. So to do this, first we let z to be lambda. All right. In fact, you can let x to be lambda or y to be lambda, whichever. So here I just chosen z to be my lambda. That means z can be any number, because this is, we're going to get an equation of a line. So z can be any number. Z here is a real number called lambda. So now I replace z, right? I replace z by lambda. So here is negative 2z become negative 2 lambda. Over here I have plus 4z become plus 4 lambda, for example, right? And now what I do now is to simplify this equation so that I can get rid of either x or y. So here I multiply this 3x with 2, so that I get 6x. Y with 2 become 2y, negative 2 with 2 become negative 4, and then negative 1 become negative 2. And then next, this 2x I multiply by 3 to get 6x. Negative 8 times 3 become negative 24. Plus 4 times 3 become plus 12. 6 times 3 become 18. So now I have 2 equations and 2 unknown. Right? xy is unknown. Lambda now is just any number. So 2 minus 1. So become negative 24 minus 2y, negative 22y. 12 lambda minus 12 lambda 1 minus 2. Sorry, I got mixed up. So 1, let me do this again. 1 minus 2. So 6x minus 6x is 0. 2y minus 24y is negative 22y. Negative 4 minus 12 is negative 16. And then negative 2 minus 18, negative 20. So simplifying this will give me 11y plus 8 lambda equal to 10. So y itself is 10 minus 8 lambda over 11. So once I get y, I can plug it back into one of these equations to find my x. So to do that, I just plug it back into this equation, or that one, whichever you like, all right? So 2x equal to 6 minus 4 lambda minus 8y, all right? And then here I can simplify this because all of these are multiple of 2. So divide everything by 2. 3 minus 2 lambda minus 4y. And y itself is 10 minus 8 lambda over 11. This number here. Okay? So then next thing is that simplifying this, I will get x equal to negative 7 plus 10 lambda over 11. So the line of intersection is made out of this parametric equation. That is, x is equal to this, y is that, and z is lambda. So this parametric equation defines the lines of intersection. Thank you. Bye-bye.